Hello. So this is we are going to study now oscillator circuits. Oscillator circuits. What is an oscillator? An oscillator produces a periodic AC signal from a DC power supply without requiring an AC input signal. For example, DC supply oscillator AC waveform. So DC energy turns into AC signal. For example, it can generate sine waves, square waves, triangular waves, sawtooth waves. So this is DC supply going to the oscillator, it becomes an AC waveform. This is the functionality of an oscillator. An oscillator produces a periodic AC signal from a DC power supply without requiring any AC input signal. For example, this is the diagram. It can generate sine waves, square waves, triangular waves, sawtooth waves. But where does the oscillation comes from? This is the interesting part. An oscillator uses feedback. Instead of taking out and feeding it back negatively like a normal amplifier, an oscillator uses positive feedback amplifier feedback network input. This is the amplifier, this is the output feedback network and gives back the input, I think. The feedback signal is in phase with the input, so it reinforces the signal. How does it start if there is no input? This is a very important question. There is always some tiny disturbance or noise in real electronic circuits. For example, tiny electrical noise amplifier, larger feedback amplifier, larger feedback. So the circuit reinforces the appropriate frequency until a periodic signal is established, so the oscillator doesn't require us to continuously provide an AC input. So we got something like, but where does the oscillation comes from? That's the interesting part. An oscillator uses feedback. We said the oscillator uses feedback. Output feedback network input. The output goes to feedback. Instead of taking output and feeding it back negatively like a normal amplifier. So for a normal amplifier, taking output and feeding back negatively, they do an oscillator uses positive feedback. An oscillator uses a positive feedback instead a negative feedback as an for a normal amplifier. So amplifier output feedback input. So positive feedback. The feedback signal is in phase with the input, so it reinforces the signal. So what I have done here is I explained what is the feedback. Let's say what is positive feedback, negative feedback. Positive feedback, a feedback signal supports or adds the input signal. So suppose here it is input signal, it is an amplifier. It amplified the signal and take some fraction of the output and adding it to the input. That is input plus feedback. Positive feedback is very important in oscillator. Here, positive feedback is important in oscillator. Negative feedback. Negative feedback, the feedback signal opposes or subtracts from the input signal. Suppose input goes to amplifier, output gets take a fraction of output and subtract from the input. So effective input, original input minus feedback. Negative feedback is widely used in improve amplifier performance. This is to improve amplifier performance. This is for oscillators. Uh, Here we can go deep. Suppose the original input is here, the feedback voltage opposes it, therefore the actual signal is entering the amplifier. Original signal E here E represents what feedback factor. Let's study feedback. Suppose the amplifier output is zero and only a fraction of it is returned. We call that the fraction feedback factor beta. This is an amplifier output. We want a fraction of it, so beta is the fraction of the amplifier output. So beta, like let's say 1 by 2, like that kind of value. That's the fraction here. So VF equals to beta V naught. Affected input we see the fraction of output. We say VF equals to feedback V naught equals to So VF equals feedback voltage, V output voltage, feedback factor. Feedback voltage is a fraction of output voltage. Beta is the feedback factor. Negative feedback. Negative feedback, see, suppose the original input is Vi. This is original input. This is feedback feedback fraction feedback voltage. This is original input voltage. Then actual signal entering the amplifier is V equals to Vi minus Vf. So suppose the feedback is given into input for negative feedback. We subtract original minus feedback a fraction of the output. That's the same for the actual signal what's happening. Since Vf equals to beta V naught, we get by subtracting this, sorry, by substituting this, we get amplifier has open loop gain V naught equals to VAVE. This open loop gain we know about open loops. I entered some in my LinkedIn page. You can read. Substitute V naught equals to V into VI minus beta V naught. Expanding V naught equals to VI minus beta V naught. This is output by input. That's all. Output by input. V naught is the output. Is the input affected input. So here comes here gain voltage gain formula is output voltage by input voltage. So this V naught equals to A in by substituting we get this and at last we get V naught by V equals to A by 1 by A beta. This is closed loop gain with negative feedback. Okay. If we substitute this, you will get the value. Closed loop gain with negative feedback. What does this actually mean? Suppose if this is some problem. We done some problem with example. The green dropped from 100 to, suppose understand the problem. Suppose A equals to 100 and beta fraction is 0.1. Gain is 100, then A beta is 10. So AF equals to feedback gain equals to 100 by 1 plus 10. AF equals to 9.09. The gain dropped from 100 to 9.9. You might ask why would we deliberately reduce the gain? Because we gains the stability and other performance improvements. That's the whole reason native feedback is so useful. Gain dropped 100 to 9.09. How much gain dropped here? Wow. This is a gain. This is the feedback you are checking like how much it dropping. The drop is from 100 to 9.09. Why native feedback gain stability? This is all used for amplifier feedback. Negative feedback gain, bandwidth, distortion, stability. Noise decreases, bandwidth increases, distortion decreases, gain stability. So we are studying oscillators. That's why I came here on oscillators because it's it after reading this, it's better to understand that. This is the interesting part. An oscillator uses feedback. Instead of taking output and feeding it back natively, like a normal amplifier, an oscillator or an oscillator uses positive feedback. How does it start? There is no input. Why there is no input? I don't understand here. How does it start if they remember? There is a very important question. There is a solid or reference. I so let's go deep here. By this thinking in your chart, you mean AC signal as input because here battery is asking what input it was getting turned into DC. Exactly, it caught an important wording issue out. When I said how does it start with the remember, I meant no external native signal or input signal. The oscillator does have a DC power supply, battery or DC supply. The battery provides the energy, but it is not itself an AC input. Think it like DC power supply, oscillator, AC output. So what actually starts the AC waveform? When you switch on the DC supply, the circuit isn't perfectly electrically silent. There are tiny disturbances or noise and transient effects uh, caused by things like thermal noise in the transistor, switching or transient when power is applied, tiny voltage or current fluctuations. Suppose there is an extremely tiny signal at the amplifier input, tiny disturbance amplifier, slightly larger signal, positive feedback, larger signal, positive feedback. The feedback network selects reinforces the desired frequency and the oscillation builds up. So remember these three things: DC supply equals to energy source, DC power provides energy, tiny noise or transient initial disturbance, tiny disturbance starts the process, oscillator output AC signal, oscillator generates AC. So yes, your statement is correct. The battery is supplying DC energy. The oscillator converts the supplied DC into a periodic frequency. If not the battery itself is being converted directly into AC. The active circuit plus feedback network uses the AC energy to sustain the AC oscillation. Hello, hello. So we will stop the DC supply energy for tiny transient equals to initial disturbance, tiny disturbance starts the process. Oscillator output equals to AC signal. Oscillator generates AC. The battery supplying DC and the oscillator converts the supplied DC energy into periodic signal. It is not that battery itself is being converted directly into AC like a transformer. The active circuit plus feedback network uses the DC energy to sustain the AC oscillation. So there is no input. There is DC power supply. The oscillator itself generating the AC output. How it's happening? The oscillator does have the battery power energy, but it is not itself. So what actually starts the AC form? When you switch on the DC supply, the circuit isn't perfectly electrically silent. The circuit inside the circuit is not electrically silent. There are tiny disturbance or noise and transient effects by things like thermal noise and the transistor. Uh, what is an oscillator? I said an amplifier with a positive feedback is an amplifier. Sorry, is an oscillator. An amplifier with a positive feedback can act as an oscillator. It's what is an oscillator? Tiny electrical noise, amplifier larger, feedback amplifier larger, feedback. The circuit reinforces the appropriate frequency until a periodic signal is established, so the oscillator doesn't require us to continuously provide an AC input. An amplifier output feedback network input again going to input output feedback network input. Here we use positive feedback. Barkhansen criteria. Barkhansen criteria there is very important for oscillator questions for sustained oscillation. Two conditions must be satisfied. Condition one, magnitude. The loop gain must be magnitude of gain and fraction. A beta equals to 1. A amplifier gain, beta feedback factor. Conditional 2, phase. Total phase shift around the loop must be 0 degrees or 360 degrees. Therefore, the feedback arranges the phase with the original signal together. Magnitude of A beta equals to 1 or magnitude angle angle of A beta equals to 0. This is Burkhardt criteria. For oscillator questions, for sustained oscillation, two conditions must be satisfied. Magnitude should be equal to 1. Phase should be 0 degrees or 360 degrees. Phase shift. Why must A beta equals to 1? Imagine A beta less than 1. Every time the signal goes around the loop, it becomes smaller, like 100, 70, 40, and 34. So eventually, oscillation dies. If A beta is greater than 1, the signal keeps increasing until practical nonlinearity is limited, called distortion. For sustained oscillation, A beta equals to 1. A beta is greater than 1, the signal keeps increasing until practical nonlinearity is limited, causing distortion. For sustained oscillation, A beta should be equal to 1. Not less than 1, not greater than, but equal to 1. What happens if less than 1? The time signal goes around the loop, it becomes smaller. It goes to smaller, smaller, smaller. If it is less if greater than 1, the signal keeps increasing. Oscillator is amplifier, external signal, amplifier, larger signal, needs an input signal. Oscillator DC supply, oscillator AC, it generates its own periodic signal. It doesn't need any input signal, it needs an input signal. That's the difference. Main types of oscillators for our syllabus we will encounter different oscillator concepts, RC oscillators, uses resistors and capacitors. Example, phase shift oscillator, usually used for relatively low audio frequencies. Also oscillators use inductors and capacitors. Examples include Hartley, Colpitts, used for high frequencies, crystal oscillator. Use the mechanical resonance of a quartz crystal to obtain very slow frequency. Where does our phase shift oscillator fit? Your next syllabus topic, phase shift oscillator is an RC oscillator. It uses transistor or OP amplifier solver section. The RC network provides the network phase shift. The important idea in the next is how can three RC sections produce the required 180 degrees phase shift which combines with the amplifier's 180 degrees phase shift to get 360 degrees. How does it start? If there is no input by this resistors. So I asked the doubt, got the doubt. It said there is no input. So I think it is a DC power supply. Then why it has no input? I thought no. So it is no signal. What it is saying is what it means. No AC signal for oscillators. The DC power supply and the noise creates the AC output. Huh? So will power phase shift process. Not listed in syllabus. The phase shift oscillator, RC phase shift oscillator. The phase shift oscillator uses a transistor amplifier, three RC sections, positive feedback. Its purpose is to generate a sinusoidal AC signal from a DC signal, DC supply. So the main purpose of this oscillator is to generate a sinusoidal AC signal from a DC power source. Then the phase shift oscillator uses a transistor amplifier, three RC sections means we know RC amplifier, it uses a capacitor. That means it has three capacitors with resistors and a positive feedback, means positive feedback to the input again. The base header transistor amplifier in C configurations produces a phase shift of 180 degrees. This means if the input is this and the collector output is inverted. So you see in the diagram it is inverted. So we have 180 degree phase shift here. But for positive feedback, we need a signal returning to the input to ultimately be in the phase with the original signal. So therefore, hello. We therefore need another 180 degrees from the feedback network. So the collector output is inverted. But my doubt is the input that means if the input is this, the collector output is inverted. Now we need uh, another phase shift. This is input, this is inverted, that's 180. But for positive feedback, we need a signal returning the input to ultimately be in the phase with the original signal. So we need another signal returning to the input. For positive feedback, we need another uh, signal returning the input from output to ultimately be in phase with original signal. So we therefore we need another 180 degrees from feedback network, RC network. So this is 180. We already have 180. But for positive feedback, we need another 180 degrees. RC network, this is the output. Output gets. We need 180 from the. That means it should be keep in the input side. RC network provides the other 180. The oscillator uses three RC sections: capacitor to ground, capacitor to ground, output input. The RC network provides the other 180 degrees. The oscillator uses three RC sections. The oscillator itself have three RC sections. Here resistor, capacitor, resistor, capacitor. Each RC section contributes approximately 60 degrees. So the three, this is 60, 50, 50, 63 quantity. So transistor amplifier 180 we are getting. The RC network is 180. This completes 360 and we got resistor equals 0. Therefore, the feedback signal arrives in phase with the original signal. Why does it oscillate? Suppose a tiny disturbance occurs, tiny signal, common input amplifier generates 180 degrees phase shift. Then RC network under 180 degrees added. 360 degrees total back to the transistor input. Because it comes back in phase, it reinforces the signal. This repeats continuously signal amplifier shift, feedback amplifier repeat. That's the oscillation. Frequency. For the common three-section RC phase shift oscillator with equal R and G, the oscillation frequency is approximately F naught equals to 1 by 2 pi RC root over 6. This is the important formula to remember. For the three equal RC sections, the feedback network attenuation is approximately beta equivalent 1 by 29 fraction, voltage fraction of feedback network. Therefore, the amplifier needs a gain of approximately A is greater than equals to 29 for oscillation to start. So we need, for example, we discussed magnitude of A beta equals to 1. If beta equals to 1 by 29, we need amplitude is greater than or equals to 1 because it needs to be magnitude of A beta equals to 1 we need for oscillation to start. That's what condition? Berkov condition. That's Berkhausen condition criteria. Berkhausen criteria is AB equals to 1 and the phase shift for the phase shift of the loop must be 0 or 360 degrees. That's the condition. So this RC satisfies the condition. Uh, then if here signal amplifier here AB equals to 1. For oscillation, this connects to directly to Barkhofen condition. We gone up to see this. Yeah. AB equals to A beta equals to greater than for sustained operation A beta equals to 1. The whole thing in one picture. PV amplifier 180 degrees. Output 3 RC stages 180 input amplifier. So the key exam points are common emitter amplifier gives 180 degrees phase. The three RC sections gives another 180. Total phase is 3. This F naught equals to 1 by 2 by RC root over 6, A equals to is greater than equals to 29. With that, phase shift oscillator is essentially covered for your at 7. Okay, what's next? Digital circuits, wave shaping might be better.